Very well. So now let's add costs. Let's make a simple assumption to keep the example simple enough that it's useful for us to understand these dynamics. So again, we're going to use cooks. So let's assume that Mike's have two inputs. Cooks, which is a variable input, right? So you have a variable input, and that's the number of workers. And in this case, those are cooks, right? And that it costs you, the cost of that is going to be $80 per day or per worker, right? Let's assume that each worker works a full day, and this comes to about $10 an hour if they work 8 hours in a day, which is kind of what Mike's saying, that he pays his workers a little more than the minimum wage. So let's use $80 per worker per day, right? So this is per worker per day. And then let's say that the only fixed input you have is the grill. The grill they have to use is, you cannot increase it because let's say Mike took a large loan to pay for this, and he's paying now the loan, and he will have to pay this loan regardless if he produces any sandwiches at all. Even when he doesn't open the store, even if he closes his business, he still have to pay for his loan. So this is in a sense a fixed input, and it will take him time to buy a new grill and kitchen and whatever. So the fixed input here is the grill, and the cost of this, let's say, is $100 per day. So now that we have those two costs, so we have that the variable cost is going to be the workers they have times the wage they pay them, which is $80. And the fixed cost is not going to be dependent on the amount of sandwiches you have or the workers you have. It's always going to be $100. With this information, you can complete the next three columns of the table, which are how much are the variable costs every time they use a different number of workers, how much is the fixed cost every time they different number of workers, and how much is the total cost every time they use a different number of workers. So here are the numbers. So when you have one worker, when you have no workers, so the first one is interesting. When you have no workers, you have some costs, which are the fixed costs. You still have to pay $100. Now, when you have one worker, you have to pay those $100 plus the cost of that worker, which is $80, so that will be $180. When you have two workers, you pay the $100 again. Fixed cost doesn't depend on the number of workers. And you pay two workers for $80 each. That's $160, so that's $260 the total cost. When you have three workers, it costs you $340 total. When you have four, it costs you $420. When you have five, it's $500. And when you have six, the total cost is $580. And again, the total cost, let's call that TC, are going to be equal to the variable costs and the fixed costs. Okay? And now what we're going to do is we're going to put that information in a diagram, because the reason we're doing this is it's easier to see patterns in diagrams. So let's put it in this way. Let's now graph the total costs, right, in dollar terms against the number of sandwiches you make, against the output. So if you graph that, you see that what you end up is with a shape, with a curve that is kind of like shaped like this, right? The costs increase by a little bit at the beginning, but then eventually they start shooting up dramatically, and they start increasing dramatically when you have 3 or 4 or 5 workers. So one thing, we call this a total cost curve. One thing that we can ask ourselves is, why does this curve has that shape? Well, I think most of you already figured this out. It probably has to do with the fact that you're paying your workers the same amount of money, but every time you hire more and more, they bring in less and less. So furthermore, we can see that if you remember, the way we graphed the total product curve was the number of workers here in the horizontal axis and the output in the vertical axis. And what we had is a curve that was like this. So what we're doing here is we're taking this Q, we put it in the horizontal axis, and we're taking the workers, we're multiplying by 80, added 100, and we put it in this axis. So what you end up with is, in essence, what we're doing is we're switching the axis. is a curve that is the mirror image of the total product curve. The total cost curve is a mirror image of the total product curve. And if the slope of this curve was due to the marginal product of labor, then the slope of this curve is also going to be driven by the marginal product of labor. In fact, the slope of this curve is called the marginal cost of production. And it tells you how much your production, the cost of production go up every time you add one more worker. And it has a very interesting application, a very important application. So we're going to get more in depth into it in the next section.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.